Hare Krishna. So, good morning, student. Now, this is my 13th video, and today I am going to teach you the higher order derivative. The name they have given as a higher order derivative, but in our syllabus, we have only the second order derivative, not the third also, not the fourth also. And at last, they have given the nth order derivative. So, we have to study only the second order, and the last unit, that is the nth order. Right? So, what do you mean by the second order derivative? It's very simple. You know what is the first order? Dy by dx. When you again find out the derivative of a dy by dx, that is called as a second order. It's very simple, isn't it? So, what is the second order derivative or the higher order derivative? They have given the name, that is the higher order derivative, but we have to study only the second order derivative because that is in your syllabus, isn't it? So, I am going to start, that is the higher order derivative. See, higher order derivative, and a special name, that is the second order derivative. Second order derivative. Now let us take one simple example. Suppose I take the example like this. Y is equal to suppose log x, isn't it? Then first order, that is dy by dx, it is also denoted by y1. It is also denoted by y dash. And what is the derivative of a log x? That is 1 by x. Now when you take ddx of dy by dx, means this is nothing but here, that is d2y. You have to read, not a d square, that is d2y. So ddx of dy by dx, it is nothing but d2y divided by dx square. This is the second order. Again, this is nothing but what here y2, and this is nothing but y2 dash. Again, you have to take the derivative. Here again you have to use the formula 1 upon x raised to n. What is the derivative of a 1 upon x raised to n? Minus n divided by x raised to n plus 1. So what is the power here? 1 means minus 1 divided by what here? X square. So this is the second order, isn't it? That is d2y. Again, if you find out ddx of d2y divided by dx square, this is nothing but d3y divided by dx cube. That is nothing but what here? Y3. And this is y3 dash, isn't it? Again you can find out minus 1. That is minus 2 divided by x cube and 2 divided by x cube. This is the third order derivative. And such a derivative, it is said to be as a higher order derivative. But when you find out d2y divided by dx square, that is the second order derivative. And that we have to study in this session, isn't it? So, again, the question is not like this, the questions they have asked. Always there is a show that and prove that, isn't it? Either show that or prove that. So, by differentiating the second order or by getting the second order, you will get a type of a differential equation. This unit also, it is helpful in the chapter differential equation. In our syllabus, they have given that is the differential equation chapter, isn't it? So the second order derivative, it is useful there also. The same type of examples repeat in the differential equation, isn't it? So every problem they have asked as a show that, prove that. So the student, प्रत्येक प्रॉब्लेमचं तर आपल्याला माहिती नसते काय शो दॅट आहे, काय प्रूव्ह दॅट, एवढं तर लक्षात राहतं. Therefore, what you have to do? Here I am giving the problem, and whatever the result, that is your show that, isn't it? So that you can write as a prove that. At once the problem is given and I write that is the show that. So don't expect this from me, isn't it? I will give the problem and whatever the result, जो काय result is, that is nothing but what is show that or prove that, isn't it? So I will take the first one. Suppose see the problem is like this. First one, y is equal to e raised to x, ax plus b, isn't it? Now you want to find out the second order derivative. Now this is one. Again dy by dx. Here you have to apply multiplication rule, isn't it? So what is the multiplication rule? E raised to x remain as it is. d dx of ax plus b. The derivative of ax, that is a. The derivative of b, that is here. Again, ax plus b remain as it is, and the derivative of e raised to x, that is e raised to x. Now here you have to be very careful, and you have to note one point. Here you have to make the reduction. Here you have to make the reduction of a problem. You have to reduce something. Now ax plus b into e to the power x, it is nothing but what here y, and that you have to substitute here, so that your problem get reduced, your function get reduced. Now dy by dx, a e to the power x, and this is nothing but what here y, and this is second, and this is from what here first, isn't it? Now again differentiate, right? When you differentiate ddx of dy by dx, means here a remain as it is, the derivative of e raised to x, e raised to x, and the derivative of y, that is dy by dx, right? So d2y divided by dx square is equal to, again you have to substitute the value a e to the power ex. From the second you will get dy by dx minus y. In place of this a into e to the power x, you can substitute dy by dx minus plus dy by dx, isn't it? Therefore d2y divided by dx square, dy by dx plus dy by dx, that is 2 dy by dx. Transfer this type, you will get 2 dy by dx minus 2 dy by dx plus y, it is equal to 0. And this is a differential equation, and they have given the problem like this, that is y is equal to e raised to ax plus b, and show that what is here, d2y divided by dx square dy by dx plus y, it is equal to 0. Right? Every time you can't remember this, but you show that. So whatever the answer you will get, that is nothing but what here you have show that, or you have do that you have to remember. But the problem, it is always like this. MCQ also, suppose they ask here, that is they write d2y divided by dx square minus 2 dy by dx, and here minus 1. This part they have given in the MCQ also, and they have asked this, and the options they have given, that is 2y minus y, y square, 3y, like this they give the option, and your option is what here, minus 1. So this is again helpful for what here, the CAT, the JEE, anything. This is the second order derivative, which is very very important, and the board also, it is very very important, right? So in this way the question in that is the MCQ question is like this, right? This part they have given. Sometimes they give even like this also, d2y divided by dx square plus y, it is equal to 2 dy by dx. अशा पद्धतीने सुद्धा विचारू शकतो, असं काही नाही, त्यांना जे वाटलं ते विचारू शकतो, isn't it? So तर प्रत्येक प्रॉब्लेमचं सोल्युशन आपल्याला इथे लक्षात राखणं. मी प्रॉब्लेम देईल, and whatever the result, that is nothing but what you show, isn't it? So another problem I will take here. Again it's very very important, because here what you have to do, every unit there is some speciality. Every unit, that is the implicit function, also the logarithmic differentiation, parametric function, that is there are the some speciality. Here also the some speciality is there. Every time you have to reduce the function by substituting whatever in the first step given, isn't it? From that you have to reduce the function and then find out the derivative, so that it is convenient for us, and you will get the result also. Second one, y is equal to e raised to x, a sin x plus b cos x. See, dy by dx. Again, apply the multiplication rule. E raised to x remain as it is. Here a remain as it is. The derivative of a sin x, that is cos x. B remain as it is. The derivative of a cos x minus sin x means minus b sin x. Again a sin x plus b cos x remain as it is, and the derivative of e raised to x, that is e raised to x. This is number 2. Again you can substitute the value a sin x plus b cos x into e to the power x. It is nothing but what your y. Therefore dy by dx e raised to x a cos x minus b sin x. This is nothing but what your y, isn't it? So again differentiate, and this is second, and this is from what your first. Again differentiate. When you differentiate dy by dx, you will get automatically that is what your d2y divided by dx is. Apply the multiplication rule, e raised to x remain as it is. Again, take the derivative of this function, a remain as it is. The derivative of a cos x minus sin x minus b remain as it is. The derivative of a sin x, that is equal to cos x. Again, bracket remain as it is, a cos x minus b sin x remain as it is. The derivative of e raised to x, that is e raised to x, isn't it? And here the derivative of y, that is dy divided by dx. Now d2y divided by dx square, e raised to x minus sin you can take common, a sin x plus b cos x plus a cos x minus b sin x into e raised to x plus dy by dx. Again, if you observe this minus sign remain as it is, but e raised to x, a sin x plus b cos x, e raised to x, a sin x plus b cos x, it is nothing but what here. Again, if you observe this, see here. Second, a cos x minus b sin x into e raised to x, a cos x minus b sin x into e raised to x, it is nothing but dy by dx minus 1. In place of this, you can substitute dy by dx minus 1 plus dy by dx remain as it is. Again, here you have got the equation like this, dy by dx plus dy by dx, that is equal to 2 dy by dx, transfer to this side, minus y minus 2y plus 2y, it is equal to 0. Right? This is your shoulder, this is your problem, isn't it? So this is the second problem. See the third. Suppose I take y is equal to x plus root of x square plus a square whole raised to m, isn't it? See, again dy by dx, apply chain rule, consider this as a u to the power m, the derivative of u to the power m into u to the power m minus 1, u means x plus root of x square plus a square whole raised to m minus 1. Again d dx of, that is what here, d dx of x plus root of x square plus a square, isn't it? Now here m, x plus root of x square plus a square whole raised to m minus 1. Here again the derivative of a x, that is equal to 1. Here root u, that is 1 upon 2 root u, means 1 upon 2 root x square plus a square. The derivative of a x square, that is equal to 2h, and the a square, that is 0, isn't it? Again here m, x plus root of x square plus a square whole raised to m minus 1. Here again cross multiplication, root of x square plus a square plus x divided by root of x square plus a square. Again, if you observe this, x plus root of x square plus a square, the power of this term, it is m minus 1. Same term is there, root of x square plus a square plus x, but its the power, it is equal to 1. When the base is same, you can add indices. Here again m, this is m minus 1 and this is 1. So m minus 1 plus 1 means x plus root of x square plus a square whole raised to power m divided by root of x square plus a square. This is nothing but m as it is. X plus root of x square plus a square whole raised to m, it is nothing but y, and divided by root of x square plus a square. Now see what you have to do. This term you have to multiply at this side, that is root of x square plus a square into dy by dx, it is equal to m. And now differentiate. Right? Now here you have to differentiate with respect to x. Again apply the multiplication rule, root of x square plus a square remain as it is. The derivative of a dy by dx, that is d2y divided by dx square plus dy by dx remain as it is. The derivative of a root of x square plus 1 upon 2 root x square plus a square, and the derivative of x square, that is equal to 2x. 2 to get cancelled. Here again m remain as it is, and the derivative of a y, that is equal to dy by dx, isn't it? Now see here again, root of here again, root of x square plus a square into d2y divided by dx square. Here again, this get cancelled. X divided by root of x square plus a square dy by dx, it is equal to n. Now see what you have to do. You have to multiply throughout with root of x square plus a square. Multiply by root of x square plus a square. When you multiply root of x square plus a square, root of x square plus a square means x square plus a square into d2y divided by dx square. Right? This get cancelled. You have got x into dy by dx, and here you have got m into root of x square plus a square into dy by dx. Right? Therefore, here x square plus a square into d2y divided by dx square plus x dy by dx. And again, if you observe this here, the result root of x square plus a square into dy by dx, it is equal to m by root of x square plus a square into dy by dx, it is equal to m by this m remain as it is, and here you have got m by means here the x square plus a square d2y divided by dx square plus x dy by dx, and the result is here m square. Right? They can give any value here. Suppose the power is 5, then what is the result here? 25 by. If the power is 6, then you have got the result is 36. If the power is 10, then the result is 100 by. In this way, you will get the short trick also. But the problem is you have to remember these short tricks, and you have to do in this way. That is your opinion or your thought, isn't it? So this is the third one. Now I will take the fourth one here. See. Fourth one. Y is equal to log x whole to the power. Simply log x. Now see, I have taken one first problem log x, but how the differential equation you will get here. Now dy by dx, the derivative of a log x 1 by x. Now see what you have to do. X you have to multiply here, dy by dx, and it is equal to, isn't it? Apply multiplication rule. X remain as it is. d2y divided by dx square plus dy by dx remain as it is. The derivative of a x1 and the derivative of a 1 is here in this way. Directly if you do, what is the second order derivative? Minus 1 upon x square, isn't it? But since we want the expression in the differential equation form, you have to do like this. X you have to transfer here and then differentiate. You will get such a type of expression. That is x into d2y divided by dx square plus dy by dx, it is equal to 0. Right? This is about the fourth one. Now I will take the fifth one here. Fifth one. Y is equal to log x whole square. Right? Again, dy by dx. This is u square, the derivative of a u square, that is 2u means 2 log x, and the derivative of a log x, that is 1 by x. Again, x you can multiply, x dy by dx, 2 log x. Right? See, apply multiplication rule, x remain as it is. The derivative of a dy by dx, again d2y divided by dx square plus dy by dx remain as it is. The derivative of a x1 and here 2, the derivative of a log x, that is 1 by x. Right? So multiply throughout, multiply throughout by x, isn't it? X square d2y divided by dx square x dy by dx is equal to. So this is the result, and this is whatever the proof that show that, isn't it? So this is the result. This is about the fifth one. Again I will take the sixth one. See, y is equal to log of log x. Again this is very important. See, log of log x. Right? Now dy by dx. Here the derivative of a log u, apply the chain rule. log u that is equal to 1 by u means 1 upon log x, and the derivative of a log x that is x. Again, there are the two terms in the denominator. One of the term you have to multiply here. So I'm going to multiply, that is x dy by dx. It is equal to 1 upon log x. No differential with respect to x. Apply multiplication rule. X remain as it is. This is d2y divided by dx square plus dy by dx remain as it is. The derivative of x. Again here, this you have to consider as a u and apply the formula 1 upon x to the power n minus n divided by x to the power n plus 1. Isn't it? Here also minus 1 divided by log x whole square, and the derivative of a log x that is equal to 1 plus 1. Isn't it? Now see what you have to do. This is first, this is second, and this is third. Here you have to substitute the value of a 1 upon log x whole square of 1 upon x from what is second. So from second, we have got dy by dx, it is equal to 1 upon x log x. Now squaring both sides. Squaring करा दोन्ही बाजूला x square log x whole square. Here what should be the term? Log x whole square, and only one x is there. Therefore, this is x square. One x you can transfer here. Here x into dy by dx whole square, it is equal to 1 upon x log x whole square. Isn't it? Now you have to put this value, put in third. If you put in third, you have got the expression like this. See here, x d2y divided by dx square, again dy by dx. Here again, that is 1 upon x log x whole square. It is nothing but what here, x dy by dx. This is minus x dy by dx whole square. Right? Now x d2y divided by dx square plus dy by dx plus x dy by dx whole square. It is equal to 0. Or up to this also you can write. Isn't it? Again, this is the very, very important example. The seventh I will take. See. Y is equal to log of x plus root of x square plus 25. Isn't it? Again, see, dy by dx. The derivative of a log u, that is 1 by u, means 1 upon x plus root of x square plus 25, and ddx of, you have to consider x plus root of x square plus 25. Isn't it? Now, dy by dx, it is equal to 1 upon x plus root of x square plus 25. Here again, the derivative of x1, the derivative of a, that is root u, 1 upon 2 root u, 1 upon 2 root x square plus 25. The derivative of x square, that is 2x. 2 to get cancelled. Right? Again, dy by dx, 1 upon x plus root of x square plus 25. Again, cross multiply. X square plus 25 plus x divided by root of x square plus 25. Again, if you observe this, the same term in the numerator, same term in the denominator get cancelled. And the term 1 upon root of x square plus 25, you can multiply it here, and root of x square plus 25 into dy by dx, it is equal to. Now here again, differentiate with respect to x. Means apply multiplication rule. See here, multiplication rule. Root of x square plus 25 remain as it is. The ddx of dy by dx, it is nothing but d2y divided by dx square plus dy by dx remain as it is. The derivative of a root u, that is 1 upon 2 root u. Isn't it? Means 1 upon 2 root x square plus 25. The derivative of a x square 2x, and the derivative of a 1 0. Right? Again throughout, multiplying throughout by root of x square plus 25. Root of x square plus 25, root of x square plus 25. x square plus 25 d2y divided by dx square. This get cancelled. Again x dy by dx. It is equal to 0. So this is about the 7th one, isn't it? Again the very important. Now the 8th one. See. 8th one. Y is equal to sine inverse x, isn't it? Now dy by dx. The derivative of sine inverse x 1 upon root of 1 minus x square. Again you can multiply here 1 minus x square dy by dx. It is equal to. Again what you have to do, apply multiplication rule. Root of 1 minus x square remain as it is. The derivative of a dy by dx, that is d2y divided by dx square, plus dy by dx remain as it is. Here the derivative of a root of 1 minus x square 1 upon 2 root 1 minus x square, and the derivative of a minus x square minus 2x, and it is equal to 0. 2 to get cancelled. Again multiply with root of 1 minus x square. 1 minus x square, 1 minus x square. 1 minus x square d2y divided by dx square. Again this get cancelled. 2 to get cancelled. Minus x divided by minus x into divided by x. This is about the 8th one. See the 9th one here. 9th. Y is equal to sine inverse of x whole square dy by dx. U square. Apply chain rule. 2 sine inverse of x. And the derivative of sine inverse of x 1 upon root of 1 minus x square. Root of 1 minus x square dy divided by dx. That is 2 sine inverse of x. Here again. Apply multiplication rule. Root of 1 minus x square remain as it is. Again the derivative of this d2y divided by dx square plus dy by dx remain as it is. Again 1 upon 2 root of 1 minus x square minus x square to minus 2x. Here 2 remain as it is. The derivative of a, that is 1 minus x square, isn't it? 2 to get cancelled. Again multiplying throughout, multiply by root of 1 minus x square. 1 minus x square, 1 minus x square. d2y divided by dx square. This get cancelled. Again minus x divided by dx. 2 to get this get cancelled. What is the result? This is sine inverse x and that is sine inverse x whole square, isn't it? So this is the 9th one here. Again 10th one. 10th. Y is equal to tan inverse of x. Again dy by dx. The derivative of a tan inverse x 1 upon 1 plus x square. Again when you have to find out directly d2y divided by dx. See here. What is the result? The power here is 1. Again ddx of this minus 1 divided by 1 plus x square whole square, and the derivative of x square, that is equal to 2x. So the direct result d2y divided by dx square, it is equal to minus 2x divided by 1 plus x square whole square. But again we want in a differential equation form. Then what you have to do? See, because they always ask, show that or prove that one and the same thing, isn't it? So what you have to do? See, again here you have to multiply 1 plus x square dy by dx. It is equal to again 1 plus x square. This is d2y divided by dx square plus dy by dx remain as it is. The derivative of a 1 0. The derivative of x square, that is 2x. This is see, this is a differential equation, and the direct result is that is x divided by the direct result minus 1 upon 1 plus x square whole square, and this is what here 2x. This minus 2x divided by 1 plus x square plus 1. This is also work in MCQs also, and this is also work, isn't it? Therefore I have given both the methods, both the results in a different form. See again 11. Y is equal to tan inverse of x whole square. Right? dy by dx. Again u square, the derivative of u square, that is 2. U means 2 tan inverse of x, and the derivative of tan inverse x 1 upon 1 plus x square. As usual, cross multiply 1 plus x square dy by dx. This is 2 tan inverse of x. Right? See, 1 plus x square. Apply multiplication rule. 1 plus x square remain as it is. The derivative of dy by dx, that is d2y divided by dx square, plus dy by dx remain as it is. The derivative of a x square 2x 1 0, again 2. The derivative of a tan inverse x 1 upon 1 plus x square. Again multiplying throughout by 1 plus x square. Here you have got 1 plus x square whole square d2y divided by dx square plus 2x. Again multiply with 1 plus x square dy by dx. Here 2 remain as it is. This get cancelled. So this is 11. So I will take the 12th one. See, y is equal to e raised to m sin inverse of x. So, m in place of m, you can substitute anything, any real number, isn't it? No dy by dx. The derivative of e to the power u, that is e to the power u. When the constant, it is multiplied to the function, constant remain as it is. The derivative of a sin inverse x 1 upon root of 1 minus x square. So multiplied here 1 minus x square dy by dx, and here m remain as it is. E to the power m sin inverse of x, it is nothing but multiply. This is second and this is from first. Now again differentiate with respect to x. Apply multiplication rule. Root of 1 minus x square remain as it is. This is d2y divided by dx square plus dy by dx remain as it is. This is again 1 upon 2 root 1 minus x square, and the derivative of a minus x square x, and here you have got, see, m remain as it is, dy by dx. 2 to get cancelled, you have to multiply throughout by root of 1 minus x square. Root of 1 minus x square, root of 1 minus x square, 1 minus x square, d2y divided by dx square. Root of 1 minus x square get cancelled, minus x dy by dx. And here again m dy by dx into root of 1 minus x square. Right? Now see, 1 minus x square d2y divided by dx square, right, minus x dy by dx. Now if you observe this, root of 1 minus x square dy by dx, root of 1 minus x square dy by dx, it is nothing but what here my, and this is m and my you can put. Therefore here you have got the result, 1 minus x square d2y divided by dx square minus x dy by dx, and it is equal to m square 13 1. Y is equal to e raised to m tan inverse of x. You see, dy by dx. The derivative of u, that is m tan inverse of x. M remain as it is. The ddx of tan inverse of x 1 upon 1 plus x square. Again 1 plus x square. Dy by dx. M remain as it is. E to the power m tan inverse of x, it is nothing but 1. Right? Apply multiplication rule. 1 plus x square. Again ddx of dy by dx, that is d2y divided by dx square. Dy by dx remain as it is. The derivative of x square 2x, and here m dy by dx. Right? Now 1 plus x square d2y divided by dx square. Again you can transfer this term like term here, dy by dx into 2x, m into dy by dx. Therefore, if you transfer this term, 2x minus m into dy by dx, it is equal to 0. This is the result, isn't it, of a 13th example. So, the next I will take, that is the 14th one. See, y is equal to cos of m sin inverse of x, right, dy by dx. Again, this you have to substitute as a u. The derivative of a cos u, that is minus sin m sin inverse of x. Again, m remain as it is, and the derivative of a sin inverse x, 1 upon root of 1 minus x square, isn't it? So here, root of 1 minus x square dy by dx, here minus m sin of m sin inverse of x. Again differentiate with respect to x. Root of 1 minus x square remain as it is. The derivative of a dy by dx, that is d2y divided by dx square, plus dy by dx remain as it is. And here again, the ddx of 1 upon root of 1 minus x square, 1 upon 2 root 1 minus x square, and the derivative of a minus x square minus 2x. Again minus a, remain as it is. Again apply the chain rule. This you have to substitute as a u. The derivative of sin u cos m sin inverse of x. M remain as it is. The derivative of sin inverse x, 1 upon root of 1 minus x square, isn't it? 2 to get cancelled. Multiply by root of 1 minus x square. Root of 1 minus x square, root of 1 minus x square, we have got as a 1 minus x square d2y divided by dx square. Again, this term get cancelled, 2 also get cancelled, x dy by dx. Here this term get cancelled, minus m into m is minus m square, and the cos of m sin inverse x, there is nothing but what you can substitute by, and this term get cancelled. This is the 14th example, isn't it? Again I will take the 15th one. 15, y is equal to a e to the power 2x plus b e to the power minus 2x, isn't it? Again dy by dx, a remain as it is. The derivative of e to the power x, e to the power 2x, 2x, and the derivative of 2x, that is 2. b remain as it is. E to the power minus 2x, derivative e to the power minus 2x, and the derivative of minus 2x, that is 2x. Again, 2a remain as it is. Here, again you have to differentiate, means d2y divided by dx square. Again, 2a remain as it is. The derivative of e raised to x, e raised to 2x, e raised to 2x. The derivative of 2x, that is 2. Minus 2b remain as it is. Again here, the derivative of e to the power minus 2x, e to the power minus 2x, and the derivative of minus 2x, that is equal to minus 2. This is 4a, e raised to 2x, plus 4b, e to the power minus 2x, isn't it? Again, if you observe this, 4 you can take common, a e to the power 2x, plus b e to the power minus 2x, and this is nothing but what you see, right? Therefore, here you can substitute by, and you have got the equation, that is d2y divided by dx square is equal to 4. This is about the 15th one, isn't it? So again, we will take the 16th one. Y is equal to x square e raised to x, right? dy by dx. Apply multiplication rule. X square remain as it is. The ddx of e raised to x, e raised to x. E raised to x remain as it is. The derivative of x square into x. Again you can substitute. See, x square e raised to x, it is nothing but y. 2x e raised to x. Right? Now differentiate d2y divided by dx square. This is dy by dx Again apply multiplication rule. 2x remain as it is. The derivative of a e raised to x, e raised to x. E raised to x remain as it is. The derivative of a 2x, it is equal to 2, isn't it? So d2y divided by dx square, dy by dx, and here you can substitute, see, 2x e to the power x, it is nothing but dy by dx minus, and this term 2 e to the power x remain as it is. Now transfer d2y divided by dx square, dy by dx plus dy by dx minus 2 dy by dx plus y, it is equal to 2 e to the power x. This is the result. Now here, so many varieties we can take there. That is it takes two time, and you are also not interested in that. Therefore, the second type of the second order derivative, that is second type, that is also very important. See the second type in this example. I am going to take the 17th example. See, suppose x is equal to 80 square and y is equal to twice 80. Find d2y divided by dx square. Right? Now x is, these are the parametric function, you know, because we have already studied it, right? X is the function of a t, differentiate with respect to t. A remain as it is. The derivative of a t square, that is 2t. Again y is equal to twice a t. dy by dt twice a, isn't it? First we want to find out dy by dx. It is nothing but what here? Dy by dt divided by dx divided by dt. Dy by dt means twice a. Twice a get cancelled. Now whenever you have to find out the second order derivative, that is ddx. And at once, the most of the student, the many student, d2y divided by dx square directly write as a minus 1 upon t square. But this is not the case, isn't it? This is not the way, because you are taking the ddx of again dy by dx, and here again ddx of 1 by t. The problem is, this is the derivative with respect to x, and your function it is of a t. This is the problem. Therefore, see what you have to do. Here you have to be very careful. First you have to take the d by dt of 1 by t and into dt divided by dx. Right? At this step, you have to be very careful. Now this is d2y divided by dx square. Here again, d by dt of a 1 by t, that is nothing but minus 1 upon t square, and dt divided by dx. See here, dx divided by dt twice at, dt divided by dx, that is 1 upon twice at. Right? And here you have got minus 1 upon 280. This is the very important problem, and most of the problem they are solving the wrong way here, right? Because at once they write d2y divided by dx minus 1 upon t square, isn't it? But here the derivative with respect to x and your function is of a t. So here you have to be very careful, isn't it? Suppose another example, x is equal to a cos theta and y is equal to b sin theta. B sin. See, again dx divided by d theta. A remain as it is. The derivative of a cos theta minus sin theta. Dy by d theta. B remain as it is. Sin theta cos theta. Right? See here. Dy by dx. Here. Dy by d theta. Dx divided by d theta. Right? Dy by d theta. That is b cos theta. And here again minus a sin theta. Right? Now minus b by a remain as it is, and this is what is cot theta. Right? So don't write at once minus b by a. The derivative of a cot theta, that is equal to minus cosec square theta, right? Because you are finding the derivative with respect to x. Therefore ddx of dy by dx minus b by a remain as it is, and ddx of cot theta, isn't it? So d2y divided by dx square minus b by a remain as it is. Here first we want to find out the derivative with respect to theta and into d theta divided by dx. Right? Minus b by a. The derivative of a cot theta with respect to theta, that is minus cosec square theta, and again substitute dx divided by d theta is equal to minus a sin theta, but d theta divided by dx you can write as a minus 1 upon a sin theta, isn't it? So here you have got minus minus plus b divided by a into a square. So there are the three minus, this and this. Since there are the three minus, you have to write minus. Again 1 upon sine you can write as a cosec. Therefore here you have got that is the cosec cube, isn't it? Because 1 upon sine, that is the cosec cube theta. This is the second type of it. That is the second type of the higher order derivative. So here you have to be very careful. So here I am finished. That is the second order derivative. So many varieties are there. In miscellaneous also the different type of a problems are there. But it is not possible to take all the problem. So I am trying to take the more and more maximum numbers of a problem, isn't it? So the student, you like my video, please share it and subscribe my channel. So goodbye.